Hey, what's up, guys? This is Chung here. So today, let's take a look at LeetCode problem number 395. Longest substring with at least k repeating characters. I mean, this is a very interesting problem to me. Okay, so the description is pretty short. Like, given like a string s and an integer k, return the length of the longest substring of s such that the frequency of each character in this substring is at least k. So some examples here, right? So the first one is we have string s here and the k is equal to 3, and the answer is 3 because the longest substring, right, whose, I mean the frequency, right, for each character is AAA. And for example 2 here, in the example 2 here, we have 5, right? That's going to be AB, AB, B. All right, so I mean, I think most people can come up with a sliding window approach, right? I mean, I think it's kind of also obvious that, it should be using the sliding window because, at least for this kind of longest substring with some conditions, right? Like either the frequency or the maximum numbers in it, right? So we usually use the sliding window, and same thing for this problem. But the tricky part for this problem is that, if you're trying to use the exactly same conditions as the to maintain the sliding window, it will not work. It will not work. So, and why is that? Because, just think about the conditions to keep a sliding window. So what kind of condition can maintain a sliding window? Just, okay, so the conditions to maintain sliding window has to be whenever we expanding whenever we expand the sliding window, that condition should be like increasing, right? And when we shrink the sliding window, that that condition should be decreasing, right? Something like the total numbers the total numbers in the sliding window, or the maximum number in a sliding window, given like all positive integers, right? Or something like the total numbers included in the total letters including in the sliding windows, right? Those things can be used as a condition to keep the sliding window. But for this problem, let's say if you're trying to use the maximum, I mean the minimum, right? The minimum frequency in a sliding window for each character is at least k. If we use this one to keep a sliding window, can it meet our requirements? And I mean, it's obviously we can, because when we are like increasing the sliding window, let's say we have A, A, B, 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 C, right? Let's say we have this one, you know. Let's say the sliding window is right here. That's gonna be our current sliding window. And if we are expanding the windows, now we're at C here, right? If we're at C here, the minimum the minimum frequency in the sliding window become now change from 3 to 1, right? And and the other way, same thing, right? When we shrink the sliding window, let's say the current sliding window is right here. That's the current sliding window, right? And so the current minimum frequency in this sliding window is 1, right? But if we shrink this sliding windows, now the max the small the minimum frequency becomes to 3. So both ways, we have a update like changing, right? We have a it's changing in the opposite direction than our definition of sliding window, right? That's why we can't just simply use the this condition to maintain the sliding window. So which means that if we want to use a sliding window approach, we have to come up with like a increasing conditions that we can use. And I think I already mentioned that one of the conditions we can use is that, I mean the total numbers, the total unique, the total unique numbers of the letters within a sliding window. That's definitely a valid condition to maintain a sliding window. And so which means that, we just need to get, the total numbers in the sliding window, unique numbers, since they're all like lowercase of English letters, right? It's like it's the at most we have 26 distinct letters, right? So we can just simply try. So basically, which means that we need to try all the possible. At most, we will need to try all 26 letters as a condition to maintain the sliding window, and then we use that conditions to traverse the entire string. And whenever we have a valid sliding windows, right? Basically, we just check all the elements in the sliding window, and if the minimum, I mean basically if all the frequency within sliding window has the if all the letters in the sliding window has at least frequency of k, right? That's gonna be our approach. All right, cool. So then let's try to run it, right? Now let's try to start the coding here. And to get our for loop range here, I'm going to get the frequency. I'm going to get the total number of basically the max number of the unique characters, right? So I'll simply use a frequency equals to counter dot s, right? And then the maximum numbers, right, will be what? Will be the length of the frequency, right? So that's gonna give us the how many distinct letters in this s here, right? And then we can just we have answer. Yeah, first we need to have answer equals 0, right? And then, like I said, we simply loop through the numbers in the range of 1 to max numbers plus 1, right? That's gonna be our for loop, right, for each of the numbers, so that we can use this number as a condition to maintain the sliding window, right? Because we need like a fixed condition to maintain the sliding window. In this case, it's gonna be the distinct letters in the sliding window. Okay, and so within that for loop here, we need like another like counter, right, to help us keep the frequency so that we can update our answers. Now we have a left equals to 0. Now, since we have like conditions that sliding window can use, now the rest will just be a regular sliding window template, right? So we have a range n here, and then so like I said, so first we always increase the expand the sliding window, and then we update the counters, right, by s dot right with s right, and then we do a plus 1, and then we will try to we'll check the sliding window, right? Maintain the sliding window, yeah, sliding window. So by doing this while loop here, while the length of the counters, right? If this one is greater than the num, right? And then okay, we'll shrink, right? We'll shrink. We'll do a left counters dot as the counters dot as left minus 1, right? And then the if counters dot as left is equal to 0, right? And then we do a delete, right? Do a delete. I'll just copy and paste this one here. That's how we maintain the sliding window, right? And then of course, don't forget to increase the left by 1. So now we have a valid sliding window. Now we just need to check Now with a valid, right, sliding window, we check the frequency. The frequency, right? So I mean here I'll just use like I'll just use like brute force way to check that. Basically, we can simply use like all, right? Basically, in Python, this all functions just give you check all the everything in that iterator, right? And they give, and if any of them is if all of them is true, and then it's true. Any of them is false, and then it is just false. So I just use this one. You can of course use using a while loop to do this with a flag, right? So here we have key and count in counter dot items, right? So basically, for each frequency in the current sliding windows, we check if the count is at least k, right? Sorry, four. I think four this one. Yeah. And if all the characters has this one greater than k, then we know okay we have find the answer, one of the answers. So that, and we just update max dot answer dot right minus left plus one, right? And then here in the end, we simply just return the answer. Yep. Yeah, I think that's it. Let's try to run the code here. Did I? Oh, sorry. I think I forgot to define the ends at the beginning here. So n is the length of s. All right. Hmm. This doesn't look right. Time limit exceeded. Did I miss anything? Uh oh, yeah. Okay, so accept it, submit. Cool. So, all right. So it passed. Mm, yeah. And how about the space, time and space complexity, right? So I think for the time complexity, so first we have like this one, right? We have the max numbers, which is what? Is 26, right? So the maximum distinct letters we have is here is 26. So I'm assuming we can ignore this for loop here, right? And then the only thing left is like this for loop. So this is of course O of n here, right? And then here is also like a 26. Here we have a while loop here, but this one will not be, since it's like a sliding window, so this is like a O1. Yeah, I would say this time complexity for this sliding window is O of n, you know. Yeah, and the space complexity is we have frequency, right? The frequency, this is at least 26, so it's like O1, right? Here we have another counters here. That's also like a O1 because at least we will need, or at most we need 26 here. So yeah, so I think space complexity for this one is O of 1. Cool. I mean, yeah, I think that's it for this approach, right? Sliding window approach. I mean, just to recap, the tricky part is that we cannot use the same conditions that the problem is asking us as a condition to maintain the sliding window. So we have to find another condition to to maintain the sliding window, and to do that we have to have a for loop because we want to include all the possible scenarios for the sliding windows, right? That's why we need to loop through all the possible all the possible the basically the unique not the unique letters, right? And for each of the unique letters. We use it as the condition to maintain the sliding window, and then we just do a brute force check for each of the valid sliding window. And yeah, and there you go. So, and that's that. Actually, for this problem, there's also like a very interesting uh, divide and conquer solutions. Even though the time complexity for that is going to be O of n squared, but I still want to mention it here, since it's kind of interesting and also a good practice for divide and conquer technique. Basically, the way it works is like this. Let's say we have a b a b a b c b b b a c c d, something like this. And the actually, so here I'll do a here, and the k is 2. So the way divide and conquer works is that we uh, we have to find a root to do the partition, right? And for this problem, we do the partition until we find a valid substring whose frequency whose the whose each letter's frequency is at least k, which means at the beginning we start from 0 and from 0 to n minus 1. And then basically we're gonna have a left for each of the divide and conquers. We always have the left and right parameters in the recursive function, right? And then from left to right, we'll calculate the frequencies for each of for we'll calculate all the frequencies within the range from left and right. So at the beginning we have 0 to n minus 1, and then that's going to be the pre-processing. And after that, we're going to loop through this left to right again, and for each of the letters, we check its frequency. If its frequency is smaller than k, then that location will be our pivot point. Basically, split the uh, we're gonna split the entire string from this location, because we know this letter we have to exclude this letter from the substring, right? So which means that, now we have what? We have this, yeah, as you guys can see here. So the C is, oh, sorry. So actually, mm, yeah, this is not a good example. So maybe I should have it here. So I should not have this C right here. Let's say there's a E here. So which means that, from C here, right? C's frequency is 1, which is smaller than 2. That's why, whenever we see a letter whose frequency is smaller than k, we'll divide this string into two halves. So this is going to be the first half, and this is going to be the second half. And for those two substrings, we'll call the same functions again, partition, right? We'll call the same functions again, and then we'll do a counters for this substring, and then we'll check if there's any character who is not satisfying this k as a frequency condition, and then we'll keep dividing until if there's nothing to be divided, and then we know, okay, that string is a valid string, and then we can simply do what? We can simply return the length for that substring. And then of course, since we're dividing into two substrings, right, and we are getting the longest, right? That's why after the split, we'll do a max of these two substrings, and then we'll return the maximum value among those two substrings. Okay, so I mean the implementation is actually surprisingly shorter, surprisingly short than this one. So, I mean, like I said, all we need is just a partition, partition like a left and right, right? And then so inside each of the partitions, we're gonna have like a default and dictionary int, right? And then I I count the frequencies inside the range here, in the range of left to right +1, because I'm including this right, the right pointers, and then we have a counters dot uh, si, right, and then si do a +1, right, and then here I'm gonna do a like middle, right? I'm going to have a middle in range of left to right +1, right? And then if, right, if if the middle, the counter of the middle is smaller than k, then we need to return the maximum of partition of left middle -1, right? Since we're excluding this middle, and then on the other side is partition of the middle +1, and then to the right, okay, right? And then in the end, we return what? The right minus left +1, right? So basically, we keep splitting these things into two halves, and then we are getting the maximum out of those two halves until we reach until we don't have to split it, and then we simply return the the right minus left +1, right? So that's gonna be our conditions to stop this partition. And then here we simply do a what? The partition, return the partitions from 0 to n-1 to, yeah, so to n-1. So we have these things, n-1. That's it. Okay, so if I run the code here, partition, I think I misspelled something here. Yeah, partition, yeah, okay. All right, cool. If I submit these things, let's see. Yes, it also passed, but it only beats like 5% of submission here because because the time complexity for this thing is like, I would say it's close to the worst case scenario. The worst case scenario is still like O of n squared, because even though we are like trying to cut this thing in half, right? But still, uh, I mean, the worst case scenario is that we always cut this strings from either the last one, or from the first one, or from the last one, right? That's why we're only reducing the size of the problems by one, not by half. That's going to be the worst case scenario. That's why the total time complexity for this one is still like O of n squared. But the best case scenario is is O of like what, n log n, right? Which means every time we cut it in half, right? That's why we have a lot n log n. I think we can still also do some like optimizations or for this kind of partitions, but I'm just showing you guys the basic idea of the how this divide and conquer solution works, and there you have it. All right, cool guys. I think that's it I want to talk about for this problem, and thank you so much for watching this video, and stay tuned. See you guys soon. Bye bye.